Every time we wash our clothes, thousands of microplastic fibers are released. They are invisible and hard to see, but they do not disappear.
Plastic pollution is one of the defining environment challenges of our time. Each year, an estimated 8 to 11 million tons of plastic enter the oceans. Microplastic, defined as plastic particles smaller than 5 millimeters, are now found across marine ecosystem worldwide, from surface water to deep sea sediments. One significant but often overlooked source of microplastic is synthetic textile. Textile fibers are estimated to account for up to 30 to 35% of primary microplastics entering the marine environment. Globally, more than 100 million tons of textile fibers are produced every year, and over 60% of these fibers are synthetic materials such as polyester. What makes this issue particularly challenging is that microfibers are continuously generated. Every time synthetic garments are washed, thousands of microplastic fibers are released. While seawater treatment plants can remove a large production of often above 80 to 90%, the sheer scale of global textile consumption means that even a small percentage escaping results in significant environmental input. This is not a significant pollution event. This is an ongoing, everyday emission driven by modern lifestyle. To effectively address this issue, we need science-based understanding across the entire textile industry and life cycle, from fiber design and fabric engineering to washing technology and policy frameworks.
In our research group, we focus on understanding how and why microfibers are released from textiles. When synthetic fabrics such as polyester are washed, mechanical force and chemical interaction cause tiny fiber to detach from the yarn structure, but not all fabric shed in the same way. We investigate how different factors influence fiber release, including fabric composition, yarn structure, washing conditions, water hardness, and abrasion during everyday wear. In the laboratory, we conducted controlled washing experiments and collecting released fiber using filtration systems. We then analyzed the number, size, and characters of these fibers. Our goal is not only to measure how many fibers are released, but to understand the mechanism behind the shedding process. Because once we understand the mechanism, we can identify where intervention is most effective. This knowledge helps guide textile design, manufacturing improvement, and future mitigation strategies.
Microplastic may sound like a distant environmental issue, but they are closely connected to everyday life. The sport jersey you wear, your school uniform, even the blanket at home often contain synthetic textiles. Each time these items are washed, tiny plastic fibers are released into our water system. But here is the important part. Challenges like these are not impossible to solve. They require curiosity, creativity, and critical thinking. They require scientists, engineers, and policy makers and designers. They require the next generation. In our research and as a scientist, we work to understand the problem at its source so that better materials and a smarter solution can be developed. And perhaps some of these future solutions will come from students like you. Microplastic fibers pass through wastewater systems. They enter natural ecosystems. Marine organisms can ingest them. Microplastic have been detected in human blood too.
The long-term health impacts are still being studied, but their presence is undeniable. The encouraging part is that this problem can be reduced. Washing clothes less frequently, using gentle cycles, choosing durable or natural fabrics where possible.
At the same time, scientific innovation is essential. Designing textiles that shed less, improving filtration systems, and informing policy through evidence-based research.